Good morning, everybody. This is Miss Rutzler, or afternoon if you're in Block 3. I am going to go through lesson 15 with you today. This is the last lesson that you are responsible for the assessment on Friday. So yesterday we worked with multiplication and division of scientific notation, and today we're going to work with addition and subtraction. Before we get started, though, you should have the 3 handouts from the front table: the lesson handout, the half sheet, which is your menu math sheet, and then the journal based on your level. You know your traditional level, whether you're A, B, or C, D. So make sure that you are grabbing your level, and then you should have a pencil. So far this week, you are responsible for lesson 13.5 from Monday, and the cool down in the inbox. Lesson 14 from yesterday, and the cool down in the inbox. And then also the must-do handout that was on the table yesterday that you also had to pick up. I have now transferred that back to the must-do box. So if you weren't here, it is in the must-do box. You can grab that. That is your first must-do from menu math this week. I came in last night for parent conferences, and I noticed that in the inbox, block 1, you do not have much in there. There is only one person, Nick, thank you very much, who has completed both cool downs and put in them in. So make sure that you are getting those done and putting those into the inbox. I should be back tomorrow. I know I said that yesterday, but I should be back tomorrow. So make sure that these 3 lessons are completed along with their cool downs and the 2 handouts now that you're going to have done for menu math. The one from yesterday, the must do, everybody must do, and then the one from today, the journal. All right, today's lesson, like I said, is about addition and subtraction of scientific notation. So if you look at your warm-up yesterday, we learned about multiplication and division, which is the first 2. And then today we're going to learn about addition and subtraction. So it really just wants you to get thinking about how you transfer those numbers and what you would result in after you add or subtract them. So take a second and mentally decide how many non-zero digits each number will have. Alright, and sorry if you're hearing Paw Patrol in the background. Alright, so number 1, I have 3 times 10 to the 9th times 2 times 10 to the 7th. So I would take their coefficients and I would multiply them, which would be 6 times 10. If I have the same base, I would be adding their exponent, so 9 plus 7 is 16. That's a pretty large number, but all it wants to know is how many non-zero digits there would be. So in this case, this would be 1. Number 2, 3 times 10 to the 9th divided by 2 times 10 to the 7th. I can rewrite that. Like we saw yesterday. So then I would have their coefficients being divided, and then I would also have their powers of 10 that I can apply the exponent rule to. So 3 divided by 2 is 1.5, and that would be times 10 to the 2nd. So again, how many non-zero digits, would there be? And that would be 2, the 1 and the 5. So if I'm looking at the last 2, I would have to transfer them and then do the operation and then compare. So if I'm looking at 3 times 10 to the 9th power, that's 3 with 9 zeros. So that would be 3 billion. 2 times 10 to the 7th power would be 20 million. And if I added them together, how many non-zero digits would there be? And that would be 2, the 3 and the 2. Similar, if I was to transfer them and then subtract them, and if you were to subtract those 2 numbers, you would actually get 3. for the last one, 3 non-zero digits. Okay, so this is where we are going today. I am going to work through activity 1 with you. Then I'm going to have you pause the video, and you are going to work through activity 2 and activity 3 on your own. And then you can come back and check your solutions or your answers. The lesson or the video itself is short because I'm just going to basically be giving you the answers at the end, but you need to work through them, and transferring them to standard form is what's going to take a lot of time. So I didn't want to sit here and write them all out. So I've pre-filled in my slides. After we get through activity 1, you have to pause it. You have to go through it on your own, and then you can continue on. Okay, so activity 1, again, our learning goal today is adding and subtracting numbers given in scientific notation. So we have activity 1, Diego, Charon, and Claire. If Neptune and Saturn were side by side, would they be wider than Jupiter? So if I'm trying to figure out the answer to that, there's 2 parts. The first one is finding out what Neptune and Saturn would be side by side, and then the second part would be comparing it to Jupiter. So number 1 is figuring out what Neptune and Saturn would be side by side, and then number 2 is comparing it to Jupiter. But in number 1, Diego, Charon, and Claire have all different ways of doing this. So Diego says that when we add the distances, we will get 4 7/10 plus 1 2/10 to give me 5 9/10. And then the exponent would be 9. So the 2 planets are 5 9/10 times 10 to the 9th. So this is a similar thinking process to multiplication and division of scientific notation, but we cannot do that with addition and subtraction. So when you are working with multiplication and division of scientific notation, you can just work with their coefficients, you can apply the exponent rule, and then you're done. With addition and subtraction of scientific notation, you have 3 rules. The first one is to transfer. The second one is to perform, meaning add or subtract. And the third one is to bring back if needed. So you're going to transfer the numbers out of scientific notation to standard form. You're going to perform the addition or the subtraction, and then you're going to bring it back if you need to. Some cases you'll need to bring it back to scientific notation, and other cases you won't. So if I was to look at these 3, Diego's way of doing this is not an option. You cannot just add their coefficients. There's only one way that you can just add their coefficients, and I'll show you how in 1 second. Charon wrote that 4 7/10 times 10 to the 4th is 47,000, which it is, and 1 2/10 times 10 to the 5th is 120,000, which it is, and then he added them together and got 167,000. So this is the idea of transfer. So transfer it to standard form, transfer it to standard form, then add them, so perform the operation, and then bring it back if needed. So in this case, we don't really need to bring it back, but if we wanted to, I can bring this back to scientific notation, which would be 1.67 times 10 to the 5th power. And then Claire says, I think you can't add unless they have the same powers of 10. So that is the only way that you can add their coefficients, is if their power of 10 is exactly the same. So if I have 10 to the 4th and 10 to the 4th, I can add them together. But initially, I have 10 to the 5th. 1 2/10 times 10 to the 5th. So how did that change to 12 times 10 to the 4th for Claire? Is she moved the decimal. If you move the decimal over, remember when we move the decimal, we're working with the exponent. And since I'm moving the decimal to the right, I would be taking an exponent away, which would then transfer this to 10 to the 4th power. 1 second, baby. 10 to the 4th power, okay? So if I have 4.7 times 10 to the 4th and 12 times 10 to the 4th, I can then add those 2 coefficients. And if I add 4 and 7/10 and 12, I would get the 16.7. Okay? And the 16.7 is not in scientific notation, but I could transfer that back, which would be the 1.67 times 10 to the fifth, because again, scientific notation, that coefficient has to be between 1 and 10. So Neptune and Saturn side by side are 1 and 67/100 times 10 to the fifth power. In number 2, it says that Jupiter has the diameter of 1 and 43/100 times 10 to the fifth. So Saturn and Neptune are 1 and 67/100 times 10 to the fifth. And Jupiter is 1 and 43/100 times 10 to the fifth. So which one is greater? I could transfer them, or you could see that since they have the same power of 10, I'm just looking at their coefficient, and Neptune and Saturn put together would still be greater than Jupiter. So this is the idea of adding or subtracting numbers in scientific notation. Okay, if you transfer, perform, and then bring back, that's all you need to do for addition and subtraction scientific notation. So if I move to the next slide, which would be activity 2, I want you to pause the video. On your table, you have a whole bunch of numbers that are in scientific notation, and the best way to do this is to transfer all of those numbers to standard form first, and then read through the questions and figure out what you're adding together. Okay, make sure you're paying attention to the labels, and then you can unpause the video and I will go through activity 2 and activity 3 with you. So go ahead and pause this video. All right, hopefully by now you have activity 2 and activity 3 completed. So I'm kind of just going to flip through, making sure that you're understanding how to transfer, perform, and then bring back. And then you can continue on with menu math. So activity 2. You are adding the distances of Mercury, Venus, Earth, and Mars from the Sun. And then you're asked, would it reach as far as Jupiter? So when I transfer Mercury, Venus, Earth, Mars from the Sun, you'll see how I transfer them to standard form. You add them together and you would get 540,900,000. And then if I compare that to Jupiter, I can either compare its scientific notation or its standard form, and the answer would be no, it's not enough. For number 2, I'm adding all of the diameter, so I'm in the different column of the table. So I would transfer their diameters, I would add those all together, and I would get 179,363, which if I look at the sun's diameter based on that, it would look to me like, okay, maybe they are greater, but if I look at their power of 10, it's an extra digit on that exponent. So really the sun is 1,392,000 versus the 179,000. So no, they would not be as wide as the sun. The sun is still wider. In activity 3, we have Old MacDonald's massive farm, and basically on the farm you've got a bunch of different animals in the different scenarios. I did forget to tell you that you did not have to do question 2, so I will not be going over question 2, but number 1, so you have 3 chickens, 2 sheep, a farmer, and a cow. So I listed them in order: 1 cow, 2 sheep, 3 chickens, and 1 farmer. I transferred them over, and then I would get 588 kilograms. Number 2, I'm going to skip over. Number 3, what is the total mass of a human, a blue whale, and 6 ants all together? Again, same idea. I'm going to transfer them and add them together. The only difference here is that when I'm dealing with the ants, I have a negative exponent. So the human is 62 kilograms. The blue whale is 190,000 kilograms. And then the last one, I would multiply the 6 times the 3, and then I would have to work with the negative exponent. So that would be 6 digits past the decimal. So if I add those all together, I'm just adding those whole numbers and the decimal together, which would be 190,062, and then out 6 places with the 18. And last but not least, it wants you to compare the bacteria to the rest of the table. So I want you to think of how far out 30 place values goes, which is pretty far. And then also remember that you're adding. You are not multiplying or dividing. You are adding those other ones together. So I have a number that goes out 9 places, 9 places, 9 places, 10. The greatest would be the zooplankton going out 20 places. And if I add all of those numbers together, there's no way that I'm going to hit 30 place values out. So bacteria will still be greater. All right, the last piece that you have to do in this lesson is the cool down. So on the back page, you have your cool down. I have written it out as a CER, or claim, evidence, and response. Your claim should be 1 sentence. Your evidence of why you're claiming that should be 1 sentence. And then the reasoning of why. So you need 2 statements saying why, or how you know, or proving what you know. So go ahead and complete that cool down. You're going to put this lesson in your binder. So this one does not go into the inbox because it's attached. And I will check this as well as the others. Once you have them in your binder, make sure that you are self-reflecting. Make sure you've self-reflected for the last 3. And then you are going to be responsible for menu math. So menu math, you have the scientific notation practice, which was the must-do from yesterday. It was on the table again. If you weren't here, it's now in the must-do, or everyone must-do box. And then the journal that you picked up today based on your level. Okay, so those 2 things you should have a good handle on by the end of class today. And then tomorrow we're going to have time to go over different questions that people have over the last 3 lessons. Hopefully I will be back tomorrow. And then you'll have time to work on your other can-do for menu math. You are not able to use Dreambox as a can-do because it was used for a part of my sub-plan on Monday. So I would really like for you to do IXL or one of the order of operation game or something like that that's still over on the counter. So if you get to that, wonderful. If not, you'll have time tomorrow. So do not worry about it. If there's a chance that I am not here tomorrow, I will be moving your test back. If I am there tomorrow and we're able to review and go over any questions that you have, then your test will still be on Friday. So I am hoping to be back tomorrow. I am hoping that my son feels better, but we will see. So I will see everybody hopefully tomorrow. If you have any questions, any issues, you are more than welcome to email me. You can send me a message on Remind, and I can try to help as much as I can through technology. So hope everybody has a good day, and I will see you soon.